The topic of this video is finding a quadratic function given its vertex and one other point. Let's look at a problem. Determine the quadratic function f whose graph is given. The vertex is 2, -4, and the other given point is 1, -1. We can see that both of those are labeled here. 2, -4 is the vertex, it's the minimum point on our parabola, and 1, -1 is the other point that the parabola goes through. All right, so let's go through the four-step process to solve a problem like this. The first thing is to identify h, k, x, and y. The vertex is h and k. The other point is x and y. And then to put them in our vertex form. The vertex form of a parabola is y equals a, open parenthesis, x minus h, close parenthesis, squared, plus k. So everywhere we see an x, y, h, or k, we're going to put numbers. A we will leave alone. So y is equal to -1, a we leave alone. X is equal to 1, h is equal to 2, k is equal to -4. Now notice that we can solve for a. Let's follow order of operations and simplify. So the first thing that we do is work with inside grouping symbols like this, 1 minus 2. So we get -1 equals a times 1 minus 2 is -1. And while we're at it, adding a negative is the same as subtraction, so I'll go ahead and rewrite that. The next step is to work with exponents, like this right here, -1 squared. Well, -1 squared is +1, so I get -1 equals a times 1 minus 4. The next in the order of operation is multiplying and dividing from left to right. We have multiplication here. A times 1 is simply a. So we have -1 equals a subtract 4. Okay, we've simplified as much as we can. Now we have to get the variable a by itself. We do that by adding 4 to both sides. And when we do, on the left side we'll have -1 plus 4, which is 3. And on the right side, the -4 and the add 4 will cancel, leaving just a. So we find that a is equal to 3. All right, so now we know the 3 pieces of information that we need to write the equation of our quadratic function. We know the value of a, we know the value of h, and we know the value of k. So we're ready to do step 3, which is to put a, h, and k into our vertex form of a parabola. So I will rewrite the vertex form one more time. This time, we're only going to replace the a, the h, and the k with numbers. Leave the x and y where they are. We need x and y to create our equation. Equations of parabolas have x's and y's in them. Okay, replace the a with 3, the h with 2, the k with -4. Then simplify. The only thing to simplify here is that adding a negative is the same thing as subtraction. So we're going to get our final answer in the vertex form, y equals 3 parenthesis x minus 2 close parenthesis squared subtract 4. I'm going to put this in a dashed box. Sometimes this is the final answer to the problem. Sometimes it's not. It depends on the instructions. This is the vertex form of our parabola. Now, looking at the problem we're solving, it says write your answer in standard form. So that means that we have a little bit more algebra to do. So we're going to take the result that we have there in the dashed circle, and we're going to rewrite this to be in the standard form. Let's begin. First, I will copy what we have from over there. Okay, next. An exponent tells you how many times to multiply a base by itself. So there's going to be 2 x minus 2's that are going to be multiplied. Next, multiplication is performed from left to right. So we're going to do this first, and that's going to give us the 3x minus 6, which will get multiplied by the x minus 2. Notice the use of parentheses here, those are required. Next, we will FOIL to perform the multiplication of our 2 binomials. This will give us y equals 3x squared minus 6x minus 6x plus 12, and then this subtract 4. Finally, combine your like terms. y equals 3x squared minus 12x plus 8. This is our final answer and is in the standard form. Okay, so let's just briefly summarize the steps. Step 1, for the 2 points that you're given, identify the values of h, k, x, and y. Plug them into your vertex form of a parabola. Step 2, solve for a. Step 3, put a, h, and k into your vertex form of a parabola. Sometimes you're done, sometimes you have to keep going. And then finally, if required, convert your vertex form equation into standard form.